Welcome to this class. In this session, we are going to see how to derive reduction formula for integrating integrals of the form cos power n of x dx for n greater than or equals to 2, and see how to apply that reduction formula to find the value of the integral of cos power 6 x dx. So this is how we start. So you see we have the integral cos power n of x dx. Now what we are going to do, we are going to rewrite from loss of indices a power n is the same as a power n minus 1 times a power 1 or just a. So this can be written as cos power n minus 1 of x times another cos x dx. We have not performed any miracle. The integrand is still the same. The next step, we now use integration by parts formula to carry out this integration. So we let this one to be u and then this one to be dv. So let u to be cosine n minus 1 x and dv to be the same as cos x dx. Now, we use chain rule to get the value of the u. You see, if we have a function y equals to u equals to cosine n minus 1 x is the same as cosine of x raised power n minus 1. So we let this one to be u. So we have y equals to u power n minus 1. So dy dx by chain rule would be given by dy du times du dx, and dy du by power rule will be n minus 1. You drop the power, and then u raised power n minus 2, subtract 1 from n minus 1, and then du dx, u is now cos x. Now when you differentiate a cos function, you get a negative sign function. So this is du dx. So which means that in this place, dy dx, dy du, which is this, times du dx, which is minus sine of x, will be the same as negative n minus 1, and then u, which is cos n minus 2 x, and then du dx was sine of x, then you multiply by sine x. So therefore, du will be given by negative n minus 1 cosine power n minus 2 x, and then times sine of x dx. And then from dv we get v. So if dv is given by cos x dx, then we should be able to get v by simply integrating both sides of that given equation, and we get v as v the integral of cosine of x dx. When you integrate a cos function, you get a positive sign function. So by integration by parts, integral of u dv is given by uv minus integral of v du. So which means our case integral of cosine power n of x dx will be uv. This v, this is u, so we'll have sine of x times cosine n minus 1 x minus v du, but there's a negative here, so we'll have plus, and then n minus 1 is a constant. I factor it out. Integral of cos power n minus 2 x sine x, and then dv is cosine of x dx. No, this is v, which is sine of x. Cos is v du, so this is the du, then this v, so sine x. So we have here times another sine x. So in simplifying, we have integral cos power n of x dx will be sine x cosine n minus 1 x plus n minus 1 integral of cos power n minus 2. This will be sine squared x dx. But we know from our basic trigonometry that sine squared x is the same as 1 minus cos squared x. So using that identity in this place, we have integral cos power n x dx is the same as sine x cos power n minus 1 x plus n minus 1 integral of cosine of n minus 1, n minus 2 x, 1 minus cos squared x dx. Now we multiply, we'll have integral cos power n x dx equals to sine x cos power n minus 1 x plus n minus 1 integral of this by this will give us cos power n minus 2x, I can say dx, and then minus n minus 1 integral of this by this. Now n minus 2 plus 2 is just n, so we'll have cos power n x dx. Now if I let this one to be I, with the integral of cosine power n x dx, then this will be I equals to sine x cos power n minus 1 x plus n minus 1 integral of cos n minus 2 x dx minus n minus 1. This is I, because I've fixed that one to be I. Now collect terms in I. So we'll have I now plus n minus 1 I equals to sine x cos power n minus 1 x plus n minus 1 integral of cosine n minus 2 x dx. Now here we have a coefficient of 1, so you have 1 plus n minus 1 times I is equals to sine of x cosine of n minus 1 of x plus n minus 1 integral of cosine power n minus 2 x dx. 1 plus n minus 1 is n, so ni equals to sine x cos power n minus 1 x plus n minus 1 integral of cos power n minus 2 x dx. Now you see, to get I, we simply divide through by n, so which means I equals to sine x cos power n minus 1 x over n plus n minus 1 over n integral of cos power n minus 2 x dx. So hence the reduction formula for the integral of cos power n x dx when n is greater than or equals to 2 is integral of cos power n of x dx is given by sine x cos power n minus 1 x divided by n plus n minus 1 over n integral cos n minus 2 x dx. So that's the first part of the question. Second part will now to be use this reduction formula to get the value of integral of cos power 6. Now cos power 6 means n is, so this is the correct formula. Cos power 6 here, n is 6, so which means our formula will be integral of cos power 6 x dx will be sine x cosine of 6 minus 1 x over 6 plus 6 minus 1 over 6 integral of cos power 6 minus 2 x dx. We just replace the value of n and start and solve it step by step. So that will give us integral of cos power 6 of x dx equals to sine x cos power 5 x divided by 6. 6 minus 1 is 5. So 5 over 6. Integral of 6 minus 2 is 4. So cos power 4 x dx. Let's call this one equation 1. We also use the formula to find the value of integral of cos power 4 x dx. Now this means n is 4, so we'll have sine x cos 4 minus 1 x divided by n, which is 4, so divide by 4, plus n minus 1, 4 minus 1 divided by n, which is 4, integral of cos raised power n minus 2, so it'll be 4 minus 2 x dx. So this will give us sine x cos power 3x divided by 4 plus 3 over 4 integral of cos squared x dx. Call this one 2. So replacing 2 in 1, we have integral of cos power 6 x. Okay, let's also evaluate this one and then before we replace. So integral of cos squared x dx will be given by sine x cosine of n minus 1. So 2 minus 1 x over n, n is 2, plus n minus 1, 2 minus 1 over n, which is 2, integral of cos, and then n minus 2, so 2 minus 2 x dx. 2 minus 2 is 0, cos x raised power 0 is 1, so it's like we have sine x cos x divided by 2 plus 1 over 2 integral of 1 dx, which is sine of x cosine of x divided by 2 plus a half x plus c. Let's call c1. So call this one 3. So this is the integral of cos squared x dx. Now putting 3 in 2, so replace 3 in 2, then 2 in 1. So 3 will be integral cos power 4x dx is given by, now I will have sine x cos power 5 okay, so sine x, so 3, putting 3 in 2, so we'll have sine power cos power 4, and then we have here sine x cos power 3 divided by 4 plus 3 over 4, and then into sine x cos x over 2 plus a half x plus c1. This will be sine x cos cubed x divided by 4 plus this will give us 3 over 8 sine x cos x plus 3 over 8 x plus 3 over 4 c1. Now this is what we replace in equation 1. So equation 1 we had sine x cos power 5 sine x cos raised power 5x over 6 plus, and then 5 over 6, and then you replace this new expression here. So sine x cos cubed x over 4 plus 3 over 8 sine x cos x plus 3 over 8 x plus 3 over 4 c1. So this will give us sine x cos power 5 x over 6 plus, now this will be 5 over 24 sine x cos cubed x and then plus, so 3 1 3 2, so it'll be 5 over 16 sine x cos x plus 3 1 3 2, so 5 over 16 x and then plus, actually I call it just c, this value y is 5 over 6 times 3 over 4 c1. So this is the integral of cos power 6 dx. So this is what you need to simplify to get the required solution. Thank you.